Hey everyone, and welcome back to the Edgeverse TechCast. This is the place to go if you have questions that need answers regarding the NXP hardware, software, and development tools that we provide for embedded developers. And I'm one of your hosts, Kyle Dando.
And I'm Bridgette Stone. Thanks for joining us. Today's conversation challenges one of the biggest assumptions in embedded design. Does a faster MCU automatically make for a better product? As it turns out, not always.
Exactly, Bridgette. Sometimes the winning design isn't built with the highest clock speed or the one with the largest memory. Instead, those designs that win choose the correct architecture. They choose the architecture that delivers predictable performance, efficient processing, and solves the usual system problems that will pop up.
And to help us unpack that, we're joined by Adrian Cano from Systems Engineering. Adrian works directly with customers evaluating the MCX N947 against competitive devices and real-world applications. Welcome to the show, Adrian.
Hey, thanks for having me. I'm Adrian Cano, and in systems engineering, I spend a lot of time helping customers evaluate microcontrollers, understand trade-offs, and match the right device to the real needs of the application rather than just chasing headline specs.
Well, let's kick it off simple, Adrian. If someone is hearing about the MCX N947 for the first time, how would you describe it?
Yeah, I'll describe the MCX N947 as a really well-balanced, high-efficiency MCU. It's designed to bring different parts of the system together in a clean and a coordinated way, even when the tasks are very different and complex. And what really stands out is how well architecture is put together. You got multiple cores, acceleration resources, and high efficiency subsystems that all of them work together smoothly. It is basically independent parts, but a unified result.
So it's not simply about having a fast processor, it's about giving developers an architecture that helps them build a more capable system.
Yeah, exactly. The architecture is doing a lot of the heavy lifting for you. Instead of pushing everything into one core or handling everything in software, it spreads the work out the right way, just letting dedicated hardware handle what it's good at.
Excellent. Well, Adrian, you and I, we sometimes will grab lunch together in Austin. And I remember the other week you were mentioning a customer success story, and it was kind of centered on the MCXN. You mentioned in that story that the MCXN solved a major problem for that customer. Without naming any customers or divulging any secrets, what were they facing?
Well, it is something that customers always face. And in this specific case, the customer was looking at a few high frequency processors that on paper on the data sheet look better than MCXN. It has higher clock speeds, more RAM, more memory. And their initial thinking was that they will need that level of hardware just to hit their performance targets.
Yeah, and that's a pretty common starting point with customers, right? They'll see that their application is super complex and they naturally say, my application is super demanding. And so they need more megahertz and more memory.
Yeah. That happened with this customer. They were trying to have some performance margin. They didn't want, of course, have any latencies or prices of race conditions on the software. And they were worried that using a smaller device might not keep up once everything was running at the same time. They had a lot of different software tasks that they wanted to run on this device. But in the complexity of the software stack and the communications, the control, the heavy math functions that they were trying to run, it will probably cause a bottleneck.
Yeah, so that's the challenge that you said the MCXN was trying to solve. It had to meet the same performance requirements as those other solutions, and you had to convince the customers that with half the processing frequency and fewer memory resources from the competitors that it was still going to meet their requirements and actually provide a really great solution.
Yeah, that's right. The challenge was to prove that the system level performance matters more than just the datasheet numbers. Once we start profiling their real workloads, actually running some of their use cases in the MCXN, instead of just comparing the specs, the picture shifted pretty quickly for them.
And so, what really surprised them?
Yeah, what they realized is that the system wasn't really bottlenecked by the CPU speed. So it came down to the fact that how efficiently tasks were scheduled, how much of the task we can run in parallel, and what could be offloaded from the core to another core or a DSP. And this is where actually the MCX N947 start to separate itself.
So let's pivot and talk about those advantages. You mentioned the dual core architecture along with the DSP and acceleration engines. What stood out most to the customer?
Yeah, what really stood out was that the acceleration wasn't just nice to have. It actually changed how they approach the software. Instead of burning CPU cycles on repetitive math processing, signal processing, or any other supporting task, they can offload the work and keep the core's focus on the application.
And that's when an evaluation starts feeling very different.
Yeah, absolutely. They saw they could keep things much more deterministic because the workload was spread out the right way. So by offloading work to the acceleration cores and the other core, it took a lot of the pressure off the main path and kept the system being very responsive, even when the communications, the control, the data processing were all happening at the same time.
So the real win here wasn't a benchmark score, it was consistent performance across the entire system.
Correct. What they really like is that the acceleration improve efficiency where it matter, and this is in the real system. So it cut down software overhead, reduced the need for constant optimizations, and got them away from running CPU close to its limits. And that's really where the MCX N947 stands out. It's built for these parallel workloads. We have the dual Cortex M33s, we have some DSPs, we have the MPU, and just as important, the architecture makes it all usable in a clean, efficient way.
All right, you're really doing a good job of clearing the story up. Talked about the megahertz and the memory, and then you just introduced the dual core. So why don't we jump in a little bit more on that? So how did the dual core contribute to the win?
Yeah, the dual core setup made much easier to split the responsibilities of the different tasks of the system. They could keep the time control critical task in one core and use the other for communications or other background tasks. So that separation made the whole system a lot more solid.
Yeah, and we hear about it all the time. It seems obvious there are two cores in a device, but what you just explained, the ability to actually map it out and use it in your architecture, that is when it really helps the customer and they see the value, right?
Yeah, of course. On the slides, you always see that dual core, it can be just another feature. But in this case, and for them, it's been a cleaner separation in the software, fewer timing conflicts, and more confidence that things wouldn't step on each other. And even with the extra processors like the DSPs, it didn't make things more complicated. Actually, it made things easier. So you can organize the system and keep things separate.
Was there one realization that really shifted their thinking?
Yeah, one of the big takeaways for them was that the MCX N947 gave them the real performance headroom without having to over-design the rest of the system. They didn't have to choose between performance and efficiency anymore. They could hit their targets with smarter, more balanced architecture instead of just jumping to a bigger processor. And on top of that, you're getting a strong integrated IP. I talk about this architecture that NXP put together. We have things like the high performance ADCs, solid USB pipeline, and other architecture features that we have on this device. So you are not just saving on compute, you're actually simplifying the whole system.
And that's a completely different way of approaching processor selection.
It really was. First, they were approaching it from top down, starting with the biggest performance numbers and only thinking about the scaling back if cost became an issue. And after working with the MCX N947, their mindset shifted. They start from the application and build from there. So looking for the device that gave them the right balance of performance, power, complexity, and actually give them more margin for future proof designs.
Well, they were very lucky to have you through this process, Adrian. And it's clear that the standout value was not just that the MCX N947 worked, it worked while keeping the design disciplined.
Yeah, they like that they could meet all the requirements without dragging along extra hardware they didn't need, and they didn't want to pay more for what they needed actually. So that has a real impact. So power, board design, software complexity, even some long-term cost. In a lot of cases, that matters way more than just saying one device runs at a higher clock speed.
And I imagine that also affects development time because if the architecture is helping you, the team spends less effort fighting the platform.
Yeah, that was a big win. They didn't have to squeeze every bit of performance through heavy optimizations anymore. The hardware was already aligned with everything that they needed. It let them move faster from evaluation to actual real implementation. They could also work in parallel. Some of the engineers can focus on the processing tasks or developing of the processing task, and the others on the communication stack. That helps speed things up quite a bit.
All right, Adrian, I think a lot of our listeners are going to appreciate that last point. Engineers do not want a part that only looks good from the marketing charts. They want a part that behaves well in their system under their requirements.
That's really where the MCX N947 built the trust with them. It wasn't just about hitting the performance target. It gave them much cleaner path to the implementation. We actually moved past the marketing slides pretty quickly, and we got hands-on, running real use cases and showing what the part could actually do. That's what at the end made it click for the customer.
Okay, but the marketing slides were really important too. But I'm sure the demos and the hands-on stuff was probably a little bit more important.
Well, maybe Kyle, instead of having to do 5 slides, we only need to do 2.
That's true. That's true. All right, well, let's make this practical for everyone listening, and they may want to evaluate this device that you just described. I'm a little surprised that there's still MCXN parts available because of how great you just made it sound. But maybe for those that were able to get their hands on the MCXN, where would you suggest that they begin?
Yeah, for sure. I was one of the lucky ones with one of those boards on my hands. And I think a great place to start is with these Freedom boards, the MCX N947 Freedom boards, and the software that it's already available. It's a really cost-effective platform. It has a lot of things in one board, so you can actually spin up demos or POCs pretty quickly with it.
All right, and beyond the Freedom Board itself, what other resources have helped your customers get started?
Yeah, I'll say the SDK examples are always super useful. They get you from the theory to working code pretty quickly. Then the application notes that my team helps to put together, the getting started docs as well. They help give you some structure to the evaluation instead of just poking around. So finally, the integrated tools for debug, configurations, and performance really help once you start adapting things to your own application.
Well, you're singing music to Kyle's ears, and it really is the complete enablement ecosystem.
Yeah, absolutely. The teams that ramp up faster are the ones that they pull everything together from day one. And thanks to Kyle, we have this in one click. So the hardware, the SDK, the examples, the documentation, all of that gives you a solid path to follow before you can actually start customizing your own system.
Okay, and now for the last bit of advice. What about for teams that are comparing the MCXN against higher speed alternatives?
Yeah, the great way to start is just to dig into the board and the software, build something simple, quick, and a bit rough to check performance and see how the system behaves. That's usually what I do. And then you're going to start refining it, splitting tasks, optimizing, all that. But the biggest thing is getting your hands early and try then running multiple activities on the MCU. And that's where the MCX N947 architecture really starts to show its strengths.
I think that's the biggest takeaway from today's discussion. The right question isn't which MCU has the biggest number, it's which MCU solves my system's problem most efficiently.
Yeah, for sure. The MCX N947 is a great example of that. It proves that having a strong architecture, the dual core partitioning, and the the integrated acceleration can outperform brute force approaches in many embedded designs.
All right, Adrian, before we wrap up, let me just summarize what I heard today. The MCX N947, as you've stated, is a highly efficient MCU that helps customers meet these demanding performance requirements, even though competing devices may offer much higher clock speeds or larger memory configurations. You outlined that the reason that it won wasn't just on luck and your good looks, Adrian. It was based on the core architecture, how that gave the customer a better way to divide their workload, and the integrated acceleration resources, how that reduced the CPU burden so that the whole system stayed responsive and easier to manage.
Yeah, that's exactly it. We have been referring to the MCX N947 in this specific application, but this is for all of the different parts on the MCXN. The real value comes from the architecture, how efficiently the system actually uses its resources. So once they saw this customer, how much useful work the MCX 947 specifically could handle everything without needing brute force specs, it stopped being about clock speed. So if you want to try it yourself, start with the Evo board, run through the SDK examples, and use tools and documentation to model your real workload early. That's where I will start to see what the device can do.
Well, Adrian, thanks again for joining us and sharing this customer story. I think it will give engineers a very fresh perspective on how to evaluate embedded processors.
Yeah, for sure. And thanks for having me. This was really great. Hopefully, this gives engineers a different way to look at it and focus more on the real system results and not just the headline specs.
And to our listeners, thanks for spending time with us on the Edgeverse TechCast. If this episode was useful, share it with a friend or a coworker who is weighing performance versus efficiency in an upcoming design.
And we'll see you next time. Keep building, keep evaluating, and take a closer look at what the MCX N947 can really do in your next embedded application. And we'll see you next time on the Edgeverse TechCast.